Hello. In these short series of videos, I will be providing some basics of probability and random variables expectations, some of the very primitive topics that's going to help you understand the more advanced topics that we will cover in this course of Bayesian machine learning. So here we go. The first topic that I would like to talk about is the probability. Probability is what makes it possible for us to implement statistical learning, the randomness that exists in life. The very basic probability experiment that we can talk about is what you see on the screen, the dice. So if we would like to estimate how it's going to end, how the output is going to be, outcome of this toss of a dice, the first thing that we can think about is to collect a number of experiments and then understand, for example, say the probability of 4 landing 4. What we would do is we would experiment however many trials that we go through, say 500 of them, and then we count all the frequencies of the outcomes, and then we can estimate the probability of say 4 using a very simplistic approach in which we can guess the probability of say one event A, to be approximated with the number of incidents that this event happens divided by all the number of experiments that we conduct. So we can call this A to be the number of times that event A happens versus the number of total trials. So this is very basic. This is high school way of approaching probability, and this methodology of estimating probabilities has a name. Since we are counting the probabilities, the frequencies of incidents, this approach is mostly referred to as the frequentist approach. However, there's a problem with this. So let's think about one very reasonable scenario in which we would like to measure the probability of some event, some rare event, so to say. Let's say the probability of miscarriage in a pregnancy. We are accustomed to seeing doctors giving some probabilities of some incidents happening, or their estimation of a likelihood, although I'm using the word likelihood quite loosely at this point, as you will see as we move on in our course, that the probability of miscarriage for a pregnancy, they present numbers like 1 in 1,000, 1 in 10,000, etc. Obviously, they do not follow the very naive and simplistic approach, the frequentist approach that I presented here for providing this number. They obviously did not wait for 1,000 pregnancies or 10,000 pregnancies and see one miscarriage happening for the set of observations that they have. So the approach that we will cover is somewhat different. In order for us to make use of the randomness in life, and in order for us to provide an opportunity to convert this problem into something that's calculatable, something that we can utilize for further modeling and machine learning, we introduce one important concept. We convert these events into let me not call it variable, although its name is has variable, some concept called random variable, right? So random variable is actually, let me put the title here. Our next topic is random variable. Random variables are nothing but tools to convert, first of all, the events into real numbers. So random variable is one, it is a function that converts events into numbers in real access, right? So what we convert, let me also write this, event to a number so that we can do some calculations. So random variable is something that we don't know the outcome of, right? So that's number one. And random variable has one other very big property, that it holds in itself the probability distribution of every single incident within the experiment, right? So it has the probability distribution. So the random variable converts events into numbers, and it also keeps in the memory the probability of each and every one of these events happening. So before I move on, before I complete the parentheses that I opened here, I would like to introduce one very big concept that you might have seen in your previous courses, that random variables are mostly represented with capital letters, right? So uppercase letter, the moment that you see an uppercase X, it represents a random variable X. And the little x that you see is the outcome, right? So in order for us to continue representing the probabilities for every event, this x, before it's taken place, is nothing but a random variable, is capital X. So I can talk about this capital X after the experiment takes place. The X takes one of the probable outcomes. So when I say probability of X equals X, it means that the capital X takes one of the values. One very simple example is, again, coin toss, heads or tails. Before I toss the coin, I hold the coin in my hand, and it is, when I'm holding it in my hand, it is nothing but a random variable. It's the capital X. And the moment that I throw it in the air and it falls, it becomes the lowercase x, right? And the lowercase x is deterministic. The moment that I look at it, I know its number. It's head or tail. I can call the lowercase x's heads or tails to be 1 and 0, because I promised that that the random variable converts events to random numbers. Events to real numbers, and 1 and 0 are two discrete real numbers. And I can then talk about the probability of capital X, the coin that I hold in my hand before I throw it on the floor, to be 1 or 0, right? So this P X equals X actually is talking about this experiment. Although, like, the representation might look odd at first, The moment that we understand that that's actually describing what's happening, the randomness and the probability that associated with this random variable that I hold in my hand before it happens, everything becomes so easy. So you can take the same thing and think about one lottery ticket. Let me make one lottery ticket. So this is let's say this is the lottery ticket that I have in my hand, and I paid $1 to purchase this, and tomorrow there will be the big lottery, and I have the chance of winning $1 million with it. I have also the chance of getting $1 from it, and very big chance of throwing in the trash and it's becoming zero, right? So all of the little x's that I can talk about some events, right? Some outcomes of this experiment. And this lottery ticket that I'm holding in my hand is nothing but a random variable. You can see it as such.